Hello viewers, today I'd like you to look at another miscellaneous equation which can be reduced to a quadratic equation. This time we're going to involve trigonometry. This is the question we have to solve to find that acute angle of those acute angles theta which satisfy this equation, that is 2 times cos squared theta minus 5 times sin theta plus 1 is equal to 0. Okay. This directly doesn't look like a quadratic equation, right? But this cos squared theta can be rewritten in terms of sin squared theta using trigonometry, and then we would have a quadratic equation in terms of sin theta. That's the method that we're going to adopt, right? So the fundamental properties of trigonometry indicate that sin squared theta plus cos squared theta is equal to 1. So we are going to replace cos squared theta with 1 minus sin squared theta, because already we have sin theta here. So it's easier to replace cos squared with 1 minus cos squared theta with 1 minus sin squared theta to generate a quadratic equation in terms of sin theta. So we have 2 into cos squared theta is 1 minus sin squared theta, 1 minus sin squared theta minus 5 sin theta plus 1 is equal to 0. So we open the brackets, right? So we get 2 minus 2 sin squared theta minus 5 sin theta plus 1 is equal to 0. We multiply both sides by minus 1 and we simplify. We get 2 sin squared theta plus 5 sin theta minus 3 is equal to 0, because 2 plus 1 is going to be 3 in this step. So when we multiply that by minus 1, we would get minus 3, right? So here we go. We have a quadratic equation in terms of sin theta. Now we are looking for those values of the variable sin theta such that two values such that their product is minus 6 and their sum is plus 5, right? We are trying to factorize this expression. That's the goal. And it's obvious, right? Minus 6 and plus 5. So minus 6 into 1 is minus 6. The product is minus 6. 6 plus minus 1 is plus 5. So 6 into minus 1 is minus 6. 6 plus minus 1 is plus 5. So the numbers that we are going to look forward to are plus 6 and minus 1. And here we go. We pull out 2 sin theta common from this into sin theta plus 3, and here it's going to be minus 1 that's common into sin theta plus 3. This is going to be equal to 0. Or in other words, 2 sin theta minus 1 times sin theta plus 3. This should be equal to 0. Right? Or in other words, sin theta is either half or minus 3, because 2 sin theta minus 1 is equal to 0 would mean that sin theta is equal to half. This would mean that sin theta has to be minus 3. Now let's look at the graph of sin theta. Right? So this is theta here. This is graph of sin theta. Let's look from 0 to 360 degrees. So this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees, right? Now we find, and this is plus 1 here, and this is minus 1 here. And the same graph repeats over and over again because sine is a periodic function. right? Now, from this graph, it's pretty evident that there is no value of theta such that sin theta is going to be equal to minus 3, because it doesn't go below minus 1, and minus 3 is, less than minus 1. So there is no theta such that sin theta is going to be equal to minus 3 for any theta. So sin theta cannot be equal to minus 3 basis this graph. So the only possibility is sin theta is equal to half, and this is pretty clear. Sin 30 degrees is half. So the acute angle, because the question is asking us to find the acute angle or angles that satisfy this condition, theta is equal to 30 degrees is the only acute angle that's going to satisfy this condition, right? So this is a simple problem which combines the principles of trigonometry as well as quadratic equations. Hope you like this problem, this solution, and we request you to subscribe to our channel, click the like button if you really like the solutions, and also take a preview at our previous videos and our upcoming videos. Thanks for watching.